Hey, Henson.
Hey.
Hey, everybody. So this is Plutus PBL live coding. It is the 14th of December, 2022. It's a Wednesday, and what we do at live coding is every Wednesday we have a presentation from somebody who's working on something that has to do with Plutus or full stack Cardano dApp development. On Thursdays, we meet at the same time, and the focus of the conversation is on the current list of projects on the Gimbal project treasury and escrow. And we're going to continue to run Wednesdays and Thursdays at this format for the foreseeable future. So I'm really excited. This is the last time we'll be doing this in December, but we're going to hit the ground running in January 2023 with another session like this one on January 4th. And we'll pick up the work of reviewing project descriptions and making sure that we're taking on the most relevant work on Thursday, January 5th. But today I've been really looking forward to this presentation. We'll get to talking about the implications of what we're looking at here later on in the meeting. But Henson, you really took the lead on building something that's critical to the development of headless dApps, to decentralized applications, and just kind of allowing people to make use of what's being built on Plutus. And I'm excited to hear you tell the story and show us how it works today. Welcome.
Yeah, thank you, James. So actually, for this open source project, originally, it's kind of a blocker of my own project as well. So it was always on my radar to solve it. But just like James said, a month ago, when I was asking around this question in the Gimbal Labs, and then James just come for me and say, hey, why don't we support you to do that, to make it open source and make it accessible to everyone. So for me, it's kind of very great news because it was always a thing that I would do anyway. But this certainly kind of made me to reprioritize my tasks and then just to make it happen as soon as possible. And I hope this tools is really helpful to the communities. So in today's live coding session, maybe I would separate this discussion into three parts. The first part, I will talk about briefly about this open source project, what it is about and what it has been built and why it is useful for fellow Plutus developers. And in the second part, we will try to do the whole process of integrating these GPD Plutus version 2 script. Particularly, I will try to integrate the escrow validator and also treasury validator together and try to spin off the local host servers. And then in the final parts, I will do a very simple demo on how to deploy it into, let's say, AWS. So, yep, it's kind of the agenda of today. And maybe if you guys have any questions, just interrupt me anytime. I hope this discussion is really helpful to everyone's attending or watching the videos. So maybe we could just get started. So just have a very brief looking into this package. Indeed, I have written a lot of different documentation about this open source project, this is the introduction of this. And inside here, we have the API documentation about what how we can use this library. And then also there are some deployment guides that some sort of trial and errors. In a later session, I will also go through it all together. And then this is another endpoint guide as well. I think we will cover it in the later sessions as well. But the message here is that pretty much when you go into this repository, you could really you could literally find out everything you need to deploy your own Plutus project into let's say a cloud server or on your local servers. So, yep. So let me have a very brief introduction on this open source project. I think everyone attending here has a brief idea of it already, but let me have a very quick walkthrough on what this is about and what kind of pain point it is solving, and what it has really built for the communities. So as we fellow Plutus developers, we might know that in our Plutus development, we use the parameterized script quite heavily because of some sort of scalability issues, such as when we build a Plutus transaction or in one script addresses, there might be some issues happening, such as double satisfactions and other kind of things. So it is always a best practice to try to split the script logics into different scripts, and also for different users, when they have no interaction with each other, it's always good for us to separate the script into different script addresses, so that in their application, they will never have any undesirable interaction between each others. But one very big pain point early on is that in all of our community learning resources, we are taught to generate a different script address inside the next shell in our own computers. That is not really acceptable in the production environment, because usually when we go into the app front end, we just want to have everything automated. So this is why this project exists. In the early days, I've tried to ask Lars in the Plutus Pioneer Program Q&A about how he approached this problem. And his answer is that in the community, there are several different methods. For himself, he prefers to do it in the Haskell language, because it makes the Plutus script development and also the deployment really streamlined and without any further, say, code translation and sort. So I just started out looking at this project by looking at what's the Haskell library that could help us to build the endpoints. So basically, in this project, I've just tried to integrate the Spock server in Haskell in order to help us to make the endpoints. We could take a very brief look into what it is really about. It's indeed very simple code, just a lot of different troubleshooting in between. So this is where all of the script logic happens. It's indeed triggering a Spock servers, and then I've implemented a bunch of different helper functions inside. And I think all of us is kind of familiar to this kind of syntax, because this is pretty much what we have been always doing when we are doing the local compiler. But instead, we are plugging into another function. It's called test envelope to JSON. It is something I dig around in the documentation. I found out that using this, I could turn the script into a JSON, and that's it. And then I apply it into different variations, like the version 1 validator, version 2 validator, version 1 maintain policy, version 2 maintain policies. So basically, you just have to choose your own instances, and then you're good to go. So I think it is a very high level overview of what this project is about. So I think everyone is maybe feeling a little bit bored starting from here. So maybe we could just jump straight into an example of how to integrate the GPT instances into this Haskell server. So here I would just start it from scratch. Yep. Oh, my keyboard is not. Yeah, it's good.
So you're pulling a project right now that does not have this endpoint integration yet.
Yep, exactly. So I would just do it from scratch altogether. kind of walk through what is the integration process usually we have to do. So here we have our GPT instances Plutus contract, right? So usually in our Plutus development, we will come up with some sort of distinction. Is that we have written our on-chain code and we have our local compiler ready, and then it's kind of in the point that we could generate one single CBOR hash for our application, but it comes to a pain point is that it's very difficult for us to generate different CBOR hashes prior to our application deploy. So it's kind of important for us to have the on-the-go capability to generate different CBOR hashes, depends on different parameters. So here we have this initialized project is at the stage of we have finished our on-chain development, but we are thinking about our deployment. So what could we do? So so basically we just have to refer to the documentation, and I would do a walkthrough. Basically, it's all of the stuff that we need to do the deployment. So first, we have to import our open source project into your own project. It's very simple. Basically, you just have to copy this tag into your CBOR project. So here, so here I go into the CBOR project and then go to the bottom of it. And then I just paste it in. So here I have a simple note to point out is that for here, it's better for us to use exactly the next node configuration. However, yesterday I've also tested, I've also tested it also works for this checkout tag as well. But for a little bit of completeness purpose, we may just try to use the whole next node configurations. So in this Plutus CBOR hash automation example here, the CBOR project, this one, these config are aligned with the next node configuration. This tag is indeed the checkout tag of the Plutus app next node tag. So for the full, just to make sure everything really works, I just copy the whole configuration here. Actually, you could always go to the IOHK's GitHub to check if it is input, output, Plutus app. You could always go to here to check for the right configurations. For here, I just show you very briefly here. This one, 97B4 C1 dot is indeed the checkout that we have just copied. And usually you could just check out the right project checkout task for different dependencies here. You just copy all the belows, these checkout as these are work for the current next node checkout app. So usually when the checkout app is updated, you can always find out the correct configurations. But here for simplicity purposes, I've already prepared it in the example folders. So I just copy all of these and then I paste it in. Don't forget to change back your package name to config to make it the same with your project. Yep. So I have this basic checkout tag. So I also add this back into. I just try to resemble the whole process. So usually you have these configurations, and when you try to integrate our open source project, you just have to paste that in. And this is the first step. Okay. So let's go back to our documentation. Okay. So the second step is to include this package into your build dependencies. So here, I go in and then I just put, because here here's the library for our project, we could just add it in at the last. And then it's good. And then, yep. Yep, and then we could just implement it by importing our packages. But I just noticed one problem that has happened is that it is a brand new project, or it is a brand new clone, so which might take us a lot of time to compile. So maybe I just going back to, let me do a little bit of housekeeping to use what I have compiled already here to just save you guys a bit of time.
Yeah, you got to plan a whole comedy routine for while Kabbalah's loading for the first time.
Yep. So usually here this hyphen new style is something that we have compiled, and then all the package would be packed into here. So in this folder, I've just tested out the whole process, what I'm going to do now. But because here we contain some of our code, so here I may just remove all of the thing we have here and try to build it here, and you taking advantage of this pre-compiled folders. So maybe just pardon me for a while for me to remove all of the stuff here. Or I could just copy that into, yeah, I think it works as well.
Well, I have a quick question. I just want to say this is beautiful. I have an NFT of a friend of mine that's stuck in a smart contract. So like I have like a side project. I'm fishing it out. So I've been like trying to compile their, but it's not. They're not doing it. They didn't do a great job to leave it so it's easily compilable. So this is really great. I already have it. I have it compiled, so it does compile, but the executable doesn't work. So this seems like it could be exactly what I need, man, to just get the CBOR and be able to run transactions to try to fish out this NFT. This is so excellent. I just wanted to say that.
Yeah, thank you.
Yeah.
So meanwhile, I do a little bit of cheating, is to move my pre-compile packages into here to save us a little bit of time. So maybe we could just proceed. So here, let's do our first step. For here, what it means is that in our Haskell file to do our Haskell servers, we just have to do this single line of import, and then we can use the packages and all of the endpoints, and that's it. So from here, we have a bit of API guys. So I might not go through that, but maybe I just go for the example here, and then everything is very clear. So usually this is a sample implementation. Usually you just have to declare your module, and then import your validators, and then import our packages. Do this simple boilerplate here, which is to create the servers, and then you just specify what is the route you want, and also what is the version of your validator or minting policy, and then just put your parameterized validator or minting policy in, and then that's it. So for the validator here, usually we have to have a type signature of taking in one parameters, and then we have a validator output, or taking a parameters and then we have a minting policy output. And this is the correct type signature to be plugged into this project. So for here, I may just copy this boilerplate into a brand new Haskell file. So here I might just make a very random name, call it SIDAN API. And then here I just do a little bit of housekeeping. And then, yep. So maybe just enlarge it by a bit. So here,
You'll want to import the V2 validator there.
Yeah.
You got that.
Am I doing the V2?
Yeah, you got it.
Never mind. We will.
I didn't
we'll
want to
just
leave that
rename it.
hanging and leave a mystery later.
Yeah. So maybe I just do the step first. We just import all of the validator we want here usually.
Oh, perfect. Okay. Oh, beautiful.
Yep. And then is it correct? Why there's some? Oh, because I'm using the full name. ASCO. Maybe I just do ASCO. Never mind. it's just the alias here.
Yep, that works.
And then I also do one for the treasury validator. Usually we will just import our validators needed here. And then we have imported these. And then usually for our endpoint creation, it's very simple to just plug in our validators. And then that's it. What we are doing here is we are using the validator inside ASCO and also the validator inside the treasury. And then why we could do that, we could just do a very simple trace back into it. The validator inside is taking one parameter and then having the validator as an output. This is our desired type signature. It's taking one parameters and then the output is a validator or minting policy, and then it will work. And same works for the treasury validator. We're taking one parameters and then the validator is the output. So we could do something like this. So for our readable purpose or completeness purpose, we may also rename our route as well. So for this route, it is something that we would use in our API endpoints. So it is really up to your choice how to name it. Like here I do the GPD ASCO, and then later I have to do something like GPD Haskell, ASCO or GPD treasury in the end of the route, and then it will work later. Okay, so let's see. Yeah, this is the API endpoint. Yeah. So maybe we could just read through it. So here we have a notice that for the parameters we need, we have to also include generic from JSON and also two JSON instances. So it is very intuitive. We just have to add the two JSON and from JSON here. Very powerful GitHub Copilot. I don't have to write code anymore. Yep. And then let's try to compile and see what we have got. Here I've already entered the next shell inside, or maybe I could just do a full demonstration. Because we are doing our Plutus app in the next node checkout tab, so we might just try to do the same process. Here we are inside a local clone of the Plutus app. I don't do the next shell compiling process altogether again because it takes some time. So I've already pre-compiled it. And here we are inside the next node checkout tab. And here is the GitHub hash of that commit, the latest commit of this particular branch. So we could just do a very quick check on this. Yep, this is the 97B4 C1 dot. And yep, here is it. And usually we want to have our Plutus app compile at the same checkout tab as our packages we are doing our Plutus development. So here I've already in this tab, and then I enter the next shell. So here we might take like 10 seconds or so. It should be really fast because I've already pre-compiled all of the packages we need in this checkout tab. Yep, just get the full directory. This takes a bit of time. Because since we do not do the housekeeping we need to do here, so probably when we try to compile, some errors will pop up. So I could just walk through the documentation about how to troubleshoot them with you here, and then I got in our working directories. So usually in our process of work, we would do a cabal web pro to see if our Plutus codes could be compiled so far. Yeah. Oh, indeed, it might work because yeah, it fails. So here, what it is complaining is that we do not have the instances imported for our particular data type inside our parameters. So we have to import them. So since the Plutus version 2, they have removed all of the orphans, including the to JSON and from JSON instances elsewhere. So usually when we just do our usual package import like these, we could not find the orphans. So what we have to do is very simple, is that we just have to import those orphans. For simplicity purposes, I've already done that part for you. Let's take a look into our source code. Here I have the default orphans taken out into from the Plutus app. So when we want to use the to JSON and from JSON for all of the I don't know if it is all, but most of the Plutus data type, we just have to import these three packages or libraries. But from here, because I've already wrapped it for our development, so we just have to import this default orphans and we are good to go. So let me do a bit of explanation here. Is that when we do this default orphans, we are able to import. Actually, we have an empty bracket here, which means that we didn't import any of our functions defined in our packages, but we are only importing the instances. And for here, the instances we want is for the particular Plutus data type, like the currency symbol, validator hash, and also token names. And then in the IOHK development team, they have developed a very simple instance declaration process for this Plutus data type. So when we import the three libraries, they could do the auto derivation for us. But for here, we also suggest to import it from JSON and to JSON from the standard libraries. It is because for some of the usual data type like integer, string, and so on, we could just take use of the standard libraries instance derivations. And we also need the generic library as well to do derivation. So because we have it here, we don't have to import it again. So here we finish our import process, and then let's try to compile again and see if it works. Yep, I think it works. So
First
here
try,
we
way to
have,
go.
yeah. Actually, it's not the first try for me. Maybe 100th time already.
Come on,
I know.
magician, don't show your secrets. We don't want to see behind that curtain.
Yep, never mind. We are enjoying the results of a couple of trials. But here we have already included that to JSON and from JSON instances. So these instances is the tools to help us to take in the JSON from our endpoint calls and then return the JSON to us. These are the use cases of the instances we need. So let's take a look into what we are missing as well. And then I think basically that's it. So let's try to also include our packages into something that we want to compile and see if there is any complaints. Okay, so here some minor issue is that is blaming for we do not have the IO. It's because in our project configuration we have also included no implied prelude, something like that. Probably, yeah, no implicit prelude. So we do not have the implicit standard libraries. So it's very simple. We just have to import it from prelude as well. Prelude. And then what we need is only, let's say, is the IO. And also from here, you may not notice this operator is also from the standard libraries. So we also include it as well. And I think it's pretty much that's it. Let's try to compile again. Yep, I think it works. Let's try it all together again. Yep, it works. So from here, we could try to spin off our package here. Because we have implemented the main function here to start off the function, the servers, we could just call this main. And then boom, we have the server live already here. So then it comes to the second part is that after we have these endpoints ready, and how can we use them? So maybe we could take the escrow example here. As that let's take a look into what this validators means. Escrow validator. In this escrow validator, we take in the escrow param and then return a validator. So let's take a look into the escrow param. Yep, here we can see the escrow param. So in the escrow param, we are taking in 4 different fields under these parameters, and then we have the currency symbol, token name. Yeah, these two type of Plutus data type. And in the process of us to crafting the endpoint, we would do something like this. Here is the escrow validator. We can see there are a lot of wrapping inside. Indeed, these are the from JSON and to JSON instances developed by the IOHK. So if we want to use their libraries, we have to follow the rules. And this is also why one of the documentation is useful, because inside this endpoint guide, basically I've already wrapped all of the common Plutus data type that you have to know. For example, here we are using currency symbol. We know that currency symbol is wrapped by the uncurrency symbol. So for currency symbol, we just have to do one more layer of uncurrency symbol wrapping in the currency symbol that we want to pass in as the parameters. And then another data type as the token name. Token name. Let's find out where's the token name. Yep, here. So the token name is a very simple wrapping as well. There's only one untoken name wrapping it in. So in our endpoint design, we just have to do the untoken name and then that's it. So here, let's see, because I have deployed it in my local machine. So I just do the local host. And then here, this is a custom routing that I have been defined here. When we are calling the endpoint, this is a route that we need to point to that specific endpoints. So let's try something. If I type the route incorrectly, I would return the 404. And then when we do this and then boom, we will get the CBOR hash. This is basically what we want to get in our terminal usually. And let's test out some of the common issues that we might have. For example, when we do the uncurrency symbol, usually there's some of the instances that we forget to wrap it. For this instances, actually it's very user friendly because you could find this very human readable error is something like that.
That's beautiful.
Yeah, expect the object but encounter the string. It's telling you that it has to be wrapped by another layer, and then that's it. And then you could just always go for this API endpoint guides to check out what is your data type and then what is needed to wrap. Something like POSIX time is indeed doesn't have to be wrapped. So I think it's very intuitive for you to use, and it covers most of the common or uncommon Plutus data type. So if you find out any uncovered areas or data type, you could always submit an issue there and probably I will add it in as well. The process is indeed very simple. It's coming back for the very basic is just to do the build and serve doors and then go to something like here. And then this is the process of how I develop the endpoint guides. It is just find out different layers and then try to include it, chart and errors, and come to this endpoint guides. But anyway, I will not delve deep into here. And
I
so,
think
yes.
a key note here is anybody who spins up a service with this project here is going to write their own endpoint guide, right? So you can use kind of the templates that you've provided, but obviously we're going to want to support people to actually use the endpoints we expose.
Yep. And then we come to a milestone here is that we have already successful to spin up a local servers. And then until this point, we still have to put it into a cloud servers. And in order to really support our devs to use the parameterized CBOR hash. And from here, I have do a very simple implementation about how to include it into our cloud. Particularly, I think I will open this for the discussion because what I'm going to cover is a specific way that I do for my project, and I'm not sure if it is the best deployment method, but just for the completeness purposes, I will also try to provide some of the guide or thoughts that I have about how to really to deploy the project. So for here, I've already created some of the code, the images, but I'm not really looking for this. Wait a second. Okay, maybe I haven't written my own deployment methods in details here. Maybe I could just cover it by hand here. So in our open source library here, indeed we have an example directory. Is actually just the trial deployment of some of the Gimbal Labs instances, and you could find very complete and comprehensive examples here. For my demonstration here, I'm also trying to copy some of the codes that have been written for that. So in my deployment method, I have declared one executable for me to do this simple implementation into the servers. So basically, I have declared a main function, main file, and then what the main file is just trying to do what we have been doing here. So it's trying to spin up the servers. So for here, I will also do the same. So give me a second to do. Yeah. So for here, I just try to clean up a bit about the cache import, because the declaration is not the same here and there. We have multiple comments here. I just try to include all of the comments here, make sure it works. This is the last comment. Yep. And then the rest, I think I could just follow through. And for the executable here, I have another source directory for app. And then inside the app, I have this main. I have this name. So basically for this main, what I have to do is just to call back our source function. And then that's it. Because I'm just too lazy, I just do the copy and pasting here. I think I just use the own name is good. Yep. And then that's it. And this is our executables. But probably we will run into some errors here. And I would let's see. Yep, because for here I've declared it as a SIDAN Plutus server. I could just do cabal run, and then it could just trigger the executables. But probably there will be some errors here. It's about the datum and parameters. Let's see. Oops, I had forgotten as well. Import. I will do it again.
I fixed all the types in the main branch of the Plutus repo yesterday. So maybe yep, you're good to go.
Oh, I see. So yeah. Originally, I was just trying to walk through. Yeah. Because in our Plutus development, sometimes we might want to add the exclamation mark here. It is specifying that we strictly need this field to be input for the parameters, but it offers some sort of type safety. But in our actual deployment, when we try to add an exclamation mark in either the param or the datum, this will crash. And I'm not sure about the reason behind. Some of the theory that I have been discussing with the community is that because when we are trying to spin out the server, the Plutus core is failed to compile because before everything happens, we do not have the parameters yet, while we have the strict declaration that we need that parameters in order to compile the script. And that might be some of the reason that is failing, but I'm not sure about the performance issue, but for the business logic itself, it should be the same about whether or not we have been including the exclamation mark. But because James has already removed that, so we are successful to do the cabal one. And then I think that is our all we need to have in order to deploy our Plutus script. So here, because I've finished the deployment, because we have finished the development, we could just try to deploy it. So I may just start it all together by creating another repo. So that's usually what we're going to do. So we create a repository, and then that is a Git basics. So I just going to push all of my code here. Let's check. If you're familiar with Git, you could probably just skip this part. And let me check the remote. Yep. Yep. So I've just pushed everything I have into this repo, and then we could try to deploy it into our server. So what comes next is our bonus session is about how I actually do the deployment of my own. Because personally, I'm familiar with the AWS more, so I might just use the AWS to be the example here. So yep, just start. So because in our Plutus development, usually we have two times of compilation. The first time is when we enter the next shell, and the second time is the first time we do the cabal repo in our Plutus in our working directory. Both of these compilation might take more than an hour to do the real compilations. So for here, what I have been done is that I have just created an image which has already do the two compilations. So if you want to have a quick start on the Plutus app next notepad, you could just always use the image that I have been already published. It should be appearing in the community images sessions. So anyway, so maybe we could just walk through it from scratch. So from here, because for the images, I have just been published to these three areas. So maybe I could just pick one. So here, because I'm already in the Hong Kong availability zone, I could just start a GPT test. So we could just, these are the DevOps that you might want to know or might not want to know. But anyway, I'll just try to walk through it. Yep, you can find it in this community AMI as well. So you just have to do the SIDAN, and then basically all of the configuration have been set. We suggest to use have I specified maybe I could update the documentation later. So upon a bit of trial and errors, in order to really to enter into the next shell, this is the minimum configuration we need: 2 core CPU and 8 GB of memories, and we could just use that. And then I just use a simple key pairs. For the security group here, what you have to do is just to expose the 8080 endpoints to the public, or you could also include other tools as well, such as different load balancers. It's really your deployment choice. But from here, I do everything very simple. Is I just expose the 8080s to the public, and then I have the T3 large configuration set. Choose the AMI, 50 GB of root volume. Just choosing these 4 configuration, and the rest is defined inside this image, and then you're good to go. So I just click it, launch instance. Yeah. And then we could try to lock it in. It's my thick pool. It's not the key that. Let's see. Yep, I think that's it. And then yeah, let's look back into our documentation. So after we have deployed the server, we will try to connect it using SSH. and then appoint the SSH. Because we have just deployed the images, we could only connect to the root user as the Ubuntu here. Using your own SSH key as chosen. So here I've chosen the here set SSH key, and we are entering in port 22. Yep, here is that we have been entering into our image, and then what we need to do is to do a little bit of housekeeping, is to move our SSH public key into also the user of SIDAN, because all of our image has been built inside these users. So it's actually very simple, just do the copy and paste, and then that's it. And then we would try to connect it together, try to connect it again using the SIDAN user. Yep, and then we have been entering our image. So inside this image, what we have got is that we have this SIDAN Plutus server, and then inside we have the Plutus app and also the Plutus template. But indeed, the Plutus template is useless. What is useful is just this precompiled folder. It helps us to save a lot of time in the real deployment. Yeah. So basically that's it. What we want to do is to either to clone our project outside, and then we move this inside our new folder, or we could just remove all of these and then try to move our project inside this folder. Either way works. So for here, I could just try to clone our project here. This is the project that we have been building in our past hours, and then we are cloning into the server. And then we have got this folder here. Because in order to use this image, we want to have this new style to be reside inside here. So either we could copy all of these into our Plutus template, or we would do another way around. So for here, I might just move everything into the Plutus template, because I'm not sure inside this cloud environment, sometimes it might have some issue when I try to copy these 1 GB file from here into another's. So maybe it's easier for me to just to remove everything here. So I'm just doing some housekeeping here just to remove everything. Yep, so I've already removed everything. So in this Plutus template folder or directory here, it's very clean now, except the precompiled file that that we need in order to save us some of the time. So what's next is we will move everything inside the our project into the Plutus template, and then we will do it recursively. Oh, we cannot do it recursively. Let's see. Plutus template. Yep. So I've already moved everything into the Plutus template. So this is our project here. And then what we need to do is, let's check out our documentation. We do the clone, and then we do then another way around, is to move everything into the Plutus template. So what we have to do is just to enter the next shell, and then we run the server. And let's see. Oops. Yep. Let's wait for the magic happens.
It's really good to see this part, this perspective. Thank you for going into deployment.
Yeah, because I just want to bring out that for the real deployment it's not really difficult as well, as long as we get everything right and then all the configuration right. And I really hope this session could help fellow developers to skip a lot of different a lot of times in troubleshooting, like choosing the instances configurations. Because personally I try to choose the 2 GB RAM and also the 4 GB RAM, and both didn't work. And when I try to do the next shell here, usually it will just pop up a kill error message, and then it's failed to enter the next shell. So yeah, I just try to walk through what it really looks like if we want to deploy our project to the public world. It might take a bit of time, although I've already compiled everything.
I was wondering, could we still get the functionality of getting the CBOR hex, just running it locally on maybe a local a Postman or something like that? I don't know what you would suggest.
Yeah, it's what we are going to demonstrate. So after the server has been spin up here in our AWS cloud, we could just do something like this in our Postman. Actually, you could see the path here is another server that I have been testing with this functionality. So for here, we could just replace it with our public IPv4 addresses. For simplicity purposes, I just use the IP here and do not do any DNS sort of things. So maybe I could just replace them.
Like, I'm wondering if we could just get it up locally, kind of like how before we went to the AWS, which is amazing, by the way. I was wondering if we could do that and then have Postman look at our local server and be able to use it like that.
Yeah, actually, I have demonstrated already, but let's do it again.
Oh, no. I just wanted to, I saw that working, but I just wanted to make sure that wasn't on another server. I just want to make sure I have all the pieces to replicate this awesome work here. That's it.
So you mean if that CBOR hex we get from the Postman is indeed the same with what we have got from the local compilation, or is it?
I can confirm that I got it yesterday.
That's all I need.
We could do a bit of experiment here as well, actually. So this is the project that we have been compiling, right? So let's say we are doing these inputs here. We're doing the escrow one, and oh, I did not have another next shell. So anyway, so I just entered it into REPL first. Here's output. Yep. So when I try to write the project escrow script, I will write the escrow script and this output directory. Yep, here, and using the inputs of, let me see here, and then when I try to apply these input into our Postman, we're doing the escrow, right? Escrow.
Honestly, the fact that you could write it to the screen right there kind of answered every question I could ever have, but I want to see this too.
Yeah, let's just go through it. The project token policy ID is here. Project token policy ID, we just paste it in. And then the project token name, okay. And then the contribute token policy ID, contribute here. And then we have the treasury issuer policy ID. Yep. Oh, we do not spin on this server yet. Whoosh. Yep, we have got this CBOR has, and we do a very simple comparison inside our GHCI maybe. Here, remember, there's no private, so I have to import it. And then for here, this is what I've got from this server response, right? So I do a equal comparison to what we've got locally from our compiler. It should be equals. Let's check. Whoa. Yeah. Yep, and they're equal. It's a very brute force testing against the two CBOR has. Anyway, we have already compiled the next shell in our cloud server here. And so what we need to do next is to go to our project here. Because we have specified our endpoint, our server's executables to be SIDAN Plutus server. So we could just do this. And then, oops, package. Do I think, let's see. It's weird, but anyway. Oops, there's nothing inside. Oh yeah, I'm sorry. Yes, I've copied everything from this into the Plutus template, so I have to go into the Plutus template instead, and then do the compile run. And it takes a bit of time to compile. Let's see if there's any weird errors popping up. Usually, if we do not have the Cabal repo precompiled, this process might take over an hour to really do the compilations. So that's kind of my motivation to create the image, kind of to spin up the deployment process. Actually, you can see that even we have the precompile, packages, we still takes a bit of time to really do the Cabal compilation process. So yeah.
Yeah, it's really forward looking that you included these pre-compiled and also just, you know, the copyable folder of everything. So thanks.
Yeah.
Not that, I mean, if you're not doing a demo, to walk away from a computer and let this run is obviously not too big a deal, but it's really nice for saving people that time.
Yeah. So maybe during this time, I could just talk about a bit how is the process of that image is built. So if you're curious about what's the image was actually the image is indeed following this is 90% assembled this the process of building the deployment documentation here. So these are the configuration I have been chosen. And then I just enter into VM and then add another users and then change it into another users. And then upon here, I'm just following the Plutus community documentation about how to build a Linux service running the next shell. Just install the package, update the package, and then spin up the and then sourcing the next script. Also adding some of the caches. And then I just clone the Plutus app and then do the checkout tab of the next node, Cabal update, and then that's it. So this is the whole process of what I've been doing. And also a very simple process is I also include the Plutus template as well, which is a kind of an empty Plutus project here. It is also a public repository. You could always refer to it. It's indeed an empty project. What it has is just to have the same checkout that as the next node configurations, and then specifying inside the library to have specifying into the project here inside the library to include everything we need. This is what I've done. It's actually just an empty project. Yeah, maybe during the time I built this image, and here we're trying to use it, I've already updated by 1 or 2 times about the checkout tab. So that's why they might take a bit of time to building our package as well. Yeah.
Not bad.
It's coming.
Not bad. It's really thoughtful, and I've been impressed by the end result, but to see today the attention to detail that you've put into this, thank you, Hinson. Really, really amazing.
Yeah. Thank you. Because as we have been discussing before, at the first time I'm building this tool, I'm also using it myself. So I was able to think from the perspective of a user. But you know what, I always appreciate any other feedbacks as well. So if any of you trying to integrate this and experiencing some issues or having any sort of feedback, to just raise an issue or just ping me up inside a Discord group, Gimbal Labs, or even just doing DM. I'm just happy to discuss more on this.
Beautiful.
Yeah, one last step.
So I'm excited to start using this presently as we start working with a couple of other communities who are going to have GPTE instances running in the near future. And then we've got a couple weeks until Playground presentation. So I know that you and Alex are bringing this to Playground on July 17th. That's for anybody who's watching this. That's the open Gimbal Labs meeting where we have a chance to talk about both technical progress, but also the implications of that progress. And so after we have this thing running for a couple weeks, I'm sure there'll be a couple of technical updates and maybe some stories of, hey, there it is, of people using this. But I'm really excited to follow up with a conversation about what it means now to have a service like this and what opportunities that opens up. I said July 17th, January 17th. Thanks, Steve. Summer vibes. January 17th, 2020.
I was like, that's a break. That's a break, James. I see you want to chill, but good heavens.
Hey,
Yeah, so we could see
Look
during the
at
time that
that.
James
So now so now any of us could go to this endpoint and spin up a GPT
Yep,
now, eh?
yep. So we just do a double checking here. Our public IP is this one, and then when we are just doing the public IP into the 8080 ports, and then we could get this returns. And yeah, I think this is a whole deployment process. And yeah, we could also test for another other instance as well. And I think yeah, basically that's it. And one one more point to note is that when we get in this port 8080s and we close the connection, our server will also be stopped. One very simple trick, and also that is the reason why I want to do it in an executable, is to add an end at the end. And then we could do the background process running. So after we have spin up the server, we just close the connection, and we could still use it. And I think, yep, pretty much that's it. And any questions?
I can't believe you packed that into 70 minutes. That was one of the most efficient master classes I've ever attended. Nice work.
Thank you.
Yeah, anybody got any questions?
I think there's so much potential with what was just shown. It's going to take some time to absorb, right, and see all the potential use cases and how this can be leveraged. It's so amazing.
Yeah. Thank you.
Hey, SIDAN, I'm wondering if is there in the code just like a list of the typeable functions that we can retrieve the CBOR from locally?
What do you mean by the typeable functions? You
Like
mean
in the
what?
yeah, like when you're in the
Yeah,
REPL,
yeah.
I think you write function. I don't quite recall them. I don't want to bother you from if they're listed somewhere, right? Because I think you did like in the REPL.
Yeah. In the REPL, probably I didn't write any function inside the REPL.
When you created the output folder and
Yeah,
you
yeah,
saved
yeah.
this CBOR, yeah.
Oh, I see. So that is actually just calling the compilation function here. I was just loading in the cabal REPL and then loading in this compiler functions, and then I try to compile a script using some predefined parameters here. And then I was just trying to get the output and then compare it to our API endpoint response. And then I think that's the only process that I use the REPL.
Got you. So when you pulled that, you're just using the GTBE way to write a script.
Yeah. And then
Perfect,
I try to do
perfect.
the comparison from that output
Yes.
and our server output.
Okay. I thought you were able to use the CBOR through the command line in the REPL, but we're going to need to get the server up and running and then ping the server to get the response.
Yeah.
Cool.
Yeah.
Thank you.
And then you could just use some front-end library such as SCOs in the React to call the endpoint and then get the CBOR hash. And then a little bit trick is that we have to do 2 times of JSON.parse in order to get the CBOR hash into an object. But anyways, you guys will figure it out. It's a very straightforward issues when it comes to the front end.
We'll put some tools together. Yeah, I'm excited to create a little front end that kind of demonstrates what's going on, building this that contract. And Jingles is here. We could talk about different sorts of resolution for, from CBOR to address, obviously is a function that will come in handy. Mesh already provides that. Yeah, this is great.
Yeah.
This is great.
So maybe in the future, if I got some capacity, I will also try to integrate this into Mesh. Maybe provide some idea from my side of building this package, or I will also work with some Mesh contributors such as Django or Kimmo. Yeah, because for my projects in the future, I also want to use Mesh as well. So it's kind of coming from the incentive of I want to use it as well. So I really want to build it for the community.
Yeah. Well, and echoing what Curtis said, you know, putting this tool in front of people enables all of us to have the next wave of ideas. And we have to be thinking about that as we refine and move towards the next iteration of the Plutus PBL course. When we launched that course in July, Mesh was in its infancy. This endpoint didn't exist. Demeter Run didn't exist, right? So the way we onboard devs is changing right before our eyes right now. And we want to make sure that people understand as much as possible, but maybe we can reduce a little bit of the friction as well. So it's an exciting moment to be watching these tools emerge and to be iterating in real time on how we share them out and what examples we can create.
Yeah. Here maybe I forgot to mention one point in the previous session is that inside here our condition of creating one endpoint is to plug in a function which take in one parameters, and then we have the validator or the maintenance policy as the output. The point is that the only requirement is one parameters. So no matter is the original parameter of your validator or you want to do some custom validator is possible as well. So here maybe I just show you a bit of simple example, but I won't code it all together from beginning. So here is our treasury parameters, right? We have we have 5 different fields. And then what if we want to kind of hard coding one of the fields, and then we expose the endpoint to taking in 4 other parameters? It's actually very simple. It's here in our treasury validator, we have the validator here, right? We just have to create another parameters which we hope the endpoints to take in. So here I have skipped one field inside the treasury parameters, and then we just have to define another custom validator, which is taking another our custom parameters, and then we output the validator and do a little bit of wrapping like this, just to hard coding what we want to put in 1 or 2 or 3 different fields, and then we are good to go. We could just use this custom validator into our endpoint construction. As long as if it fails taking in one and only one parameters and then output a validator or a maintenance policy, this endpoint library will work. Yeah, just to add a bit of safety to your project, to hard coding. Let's say you have a identifier token that always have to be put into the parameters. You could try to do something like this.
Yeah. There's great implications to explore there too.
Yeah, I think the other way is the same. Like if your validator is taking in more than 1 parameters, you could always do a helper function to take in one parameters and then feed into your own validators to get the validators or to get the correct type signature to put in. You just have to do a little bit of wrapping on your own.
Yes.
Yeah.
Well, thank
Any
you.
questions?
Yeah. Any last questions? I'm so excited to play with this. I'm so excited to practice deploying it elsewhere. I'm going to follow your Amazon docs, but make sure to make sure I can run it on different cloud servers. And this also sets the stage for, you know, why we want to continue to build out the Dandelion layer, because we want services like this to be robust and decentralized, just like the contracts we're building and the protocol we're building on. So it really gives us some excellent hands-on next steps to cover over the next few months. And I know this is going to be an ongoing conversation. I'm really fired up to hear what this inspires people to do.
Yeah. So maybe just one very quick closing remark. If you appreciate what we have been doing so far, it's very simple to support us. To just give our repository a start, or also consider staking in our pool. Actually, we have been starting this pool, stake pool, like 1 year ago, and we didn't do any marketing so far. And right now we are trying to really start to doing something for the community, and also we're starting our project very soon as well. So we are now cleaning up everything in our stake pool, like rotating the key, and also checking again all of the configuration of the cloud as well. So I think everything will just starting to happen very soon. Another way to support is also if you have any feedback just to create an issues, I think it's helpful to everyone in the community. And also for me, I would take it as a learning opportunity to see what I could improve in this open source project. And I think that's it. Just hope you guys have been enjoying this session, and hope this project is really helpful to for every deployment. I think since this capability has been brought out to the community, there are a lot of more different business logic in Plutus smart contract could be done. I'm really excited to see if anything could happen on Cardano and make this chain better and the community better. Yeah.
Great. Thank you. Wait 1 second, I'll be right back.
Yeah.
It's really great stuff, man. And I wasn't aware you had a stake pool. I'm just kind of oblivious on that level, but now that I know, it's on my radar, so I appreciate it.
Yeah, thank you, man.
Yeah.
Hope it's really helpful, really.
I'm really fired up, Hinson, to see, your projects take flight. Thanks for building this component. And yeah, there's a lot in common with the story of Mesh that was initially built by the Martify team. They looked at it and they said, look, we need these tools to do the things we want to do. Build some tools, open source them, continue to open up new questions and new applications. So I really appreciate how this network of open source tooling is coming together right now. Excited to see what happens next year. We're going to have some fun in 2023, putting these things to use and seeing what's next.
Yeah.
Thanks. All right, I'm going to stop recording now. If you were checking out this video, just stop by Gimbal Labs and ask questions about what we're up to anytime. See you soon.